Okay, we'll continue last class problem. So you need to draw the cam profile. So based on the simple harmonic motion for a knife edge follower. So you have drawn the displacement diagram here. So to draw the displacement diagram, so you need to draw one horizontal line for a one complete revolution. That is what a 360-degree here. Okay. So let us take an AX line with a suitable scale. AX line with a suitable scale. So then based on the angle of outstroke, angle of dwell at a top position or at a rise position, as well as angle of return position. So you just divide this AX line, that is what angular displacement line, okay, into required degrees. Okay. So now AB is what angle of 90-degree for outstroke. Again, dwell at top position it is a 30-degree. Again 60 degrees is what angle of return. Okay, so angle of return. Okay, so now rest of the angle is 180-degree is a dwell at lower position. Okay, dwell at lower position. So now draw AY line, draw a AY line, so in a such a way that it should be equal to the rise of the follower or stroke of the follower. Now stroke of the follower here it is a 40 mm. Stroke of the follower is 40 mm. Okay, now you just draw a line AY as a 40 mm. Okay, now as you need to get the simple harmonic motion, so draw a circle. Okay, so taking half of this AY distance as a radius and draw one semicircle here. Draw one semicircle. Okay. So now divide this semicircle into equal number of parts as you are going to divide these outstroke angle as well as return stroke angle. Now we have divided this in 6 parts, this one also in 6 parts, then you need to divide this is also in a 6 parts. Then draw the horizontal line, so from the point of intersection over this semicircle. Okay. Now you have a point A, B, C, D, E, F here. Now you just draw the horizontal lines. Okay. Now wherever intersecting this first division with the first line, put a mark. Similarly, last division, put a mark for this horizontal line. Then you go on marking the points here. Then you draw the smooth curve passing through the points of intersection for this horizontal division lines as well as vertical division lines. Okay. You are going to get the displacement profile. You are going to get the displacement profile. So next thing is you need to draw the profile of the cams here. Profile of the cams. Now let us look out here. Profile of cams. Profile of the cam when the line of stroke of the follower passes through the axis of camshaft. Okay, this is what a first bit. This is what a first bit. Okay. Now how to draw this? Now first you draw the base circle. First you draw the base circle. Okay. So this base circle diameter is 40 mm. Okay, base circle diameter is 40 mm. Okay. Now, so as you need to draw the profile in a such a way that in a rotation in the opposite direction, as keeping the cam as a constant one, as keeping the cam as a constant one, and follower is going to rotate about its circumference. That is what based on the kinematic inversions. Okay. Now let us draw the position of follower on this axis. Condition is that, so line of stroke of the follower, okay, line of stroke of the follower passes through the axis of the camshaft. Okay? Axis of the camshaft. Now let us draw the follower here. Right? Now, as it is starting point of outstroke, okay, so let us divide the angles on this circle with respect to this point. Now let us take this is a what O, okay, this is what A, right? Now you just divide circle for an angle of 60 degree here. This is what B, okay, this is what B. How much angle it is? 90 degree, okay, it is 90 degree. Wait. Now here it is a 90 degree. Okay. Now next angle is 30 degree. Okay. Next angle is 30 degree. So this is what 90 degree. So now remaining angle for outstroke it is a 60 degree. Remaining angle for outstroke it is a 60 degree. Okay. So now this is what a C. Now this is what a D. Okay. Now divide the ABR into equal number of parts. How many parts you have done for this displacement position or displacement uh, length? Okay. Now it is a 90 degree. We have divided it is in a 6 number of parts. So now let us divide this AB into 6 number of parts. Let us divide this AB into 6 number of parts. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Now angle it will come for every division it is a 15 degree. Okay. Angle between every division is a 15 degree. Right. Now let us mark these points. Now this is what O here. This is point 1. This is point 2, point 3, point 4, 5, and 6. Right? Similarly, make a number of divisions on this arc CD equal to 6 here. Now in this case, you will get 10 degree intervals. You will get 10 degree intervals. Okay. Now this is what 0, 1, 2, 3, 4, 5, 6. Now let us go for dash here. 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Right? Now, to draw the profile, measure the length on respective points here. Now this is about a point 1. It is the A dash. Okay. It is about a dash. Now A0 is on the same point. So here it is a A0. Okay. Now let us mark point here. This is what A dash. This is what B dash, C dash, D dash, E dash, and F dash. Right? 2B dash. Now 2B dash. 3C dash. 3C dash. 4D dash. 4D dash. 5E dash. Okay. And 6F dash. Right? And now You just join these points with a smooth curve. Okay? You just join these points with a smooth curve. Now the same arc is going to continue here. Okay, because it is what a dwell there, because it is what a dwell there, right? Now mark the points on CD curve extended lines. CD curve extended lines. Okay. Now let us go for, this is what O dash, G dash, O dash, H dash, I dash, J dash, K dash, sorry, L dash and M dash. Okay. Now you just join the smooth curves here. Now the cam profile is, now this is what a cam profile. Okay, this is base circle. This is what a base circle. Clear? Okay, next we'll go for profile of the cam when the line of stroke of the follower is offset 20 degree from the axis of the camshaft. Now, drawing of cam profile is same for every motion of the follower. Whether the motion is uniform velocity, whether the motion is uniform acceleration, whether the motion is simple harmonic, or whether the motion is cycloidal. The thing is that you need to draw the displacement diagram. Okay, then divide the outstroke angle and return stroke angle, then join the points and you'll get the curve. Now measure the points. Okay, and you need to draw the same division on the cam profile also. Then you will go on joining the points, right? Now for this offset, we'll go for now offset. So now when follower is offset 20 mm from the axis of the cam, from the axis of the camshaft. So now for this case, first you need to draw the offset circle, okay, then base circle. Now let us look out here. First you draw the offset circle, okay. So this is of 20 mm radius. Okay. Next you draw the base circle. Next you draw the base circle. Okay. So circles are not exact in for, I'll redraw. Now you have drawn offset circle and base circle. Okay. So now inside circle is the offset circle. Okay. So which has a radius of 20 mm, and this outer circle is what, base circle, a radius of 40 mm. Now if you just draw a tangential line here, okay, a tangential line for this offset circle. Okay. Now I'll draw tangential line here. Now this is what position of cam now. Sorry, this is what position of follower. Right? Position of follower. Now you need to divide the angles with respect to the position to the center point of camshaft. Okay. Now I'll just join this point here. Okay. Now this point is what, A, this is what, O. Now with reference to the OA, what is the outstroke angle? Outstroke angle is 90 degree here. Okay. Outstroke angle is 90 degree. Dwell stroke angle is 30 degree. Then return stroke angle is 60 degree. Now points are A, B, C, D. Right? Now this is what angle 90 degree here. This is 30 degree. This is what a 60 degree. Okay. Now divide the angles again here. Okay. Now I will divide this one. Now I will divide this one into 6 number of parts. Now angle is what? 15 degree. 1, 2, 3, 4, 5, 6. Right. Now this is what a 0. 1, 2, 3, 4, 5, 6. Right? Now you draw the extension lines in a such a way that you draw extension lines of these intersection points in a such a way that those points will become, the line which is drawn from those points will become tangent to the offset circle. Tangent to the offset circle. Now this is what a point 1 here. Okay. Now I will just draw one line. So similarly draw for other points also. Now this was a point C here. Now divide this one into 6 number of parts. CDR. Right. This is what O dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Okay. Now we join the points. Those lines which are going to pass through the points 1 dash, 2 dash, 3 dash, 4 dash are should be tangential to the offset circle. Right? Now next thing is that you need to measure the distances here. Here this will come A dash, B dash, C dash, D dash, E dash, F dash. Now this is what G dash, H dash, I dash, J dash, K dash, L dash, and M dash. Right? Now you join with a smooth curve here. Right? This is what cam profile. Okay? This is what cam profile. Okay? So now you note down one problem here. You try to do yourself first. You try to do yourself first. Okay? A cam with a minimum radius of, you note down quickly, I will not write on the board, I will just dictate. You just note down. A cam with a minimum radius of 50 mm, rotating clockwise, rotating clockwise at a uniform speed, at a uniform speed, is required to give a knife edge follower the motion as described below. The motion as described below. You note on first bit, to move outwards, to move outwards through 40 mm, through 40 mm during 100-degree rotation of the cam. During 100-degree rotation of the cam. Second, to dwell for next 80-degree. To dwell for next 80-degree. Third bit, to return its starting position, to return its starting position during next 100-degree, during next 100-degree. And fourth, to dwell for the rest period of a to dwell for the next to dwell for the rest period of a revolution, that is 80-degree. Now draw the profile of the cam. Draw the profile of the cam. I think for last class problem we have not calculated velocity, acceleration, everything. Okay, not just. Draw the profile of the cam. First, when the line of stroke of the follower when the line of the stroke of the follower passes through the center of the camshaft, and when the line of the stroke of the follower is, and second one, when the line of the stroke of the follower is offset by 15 mm. offset by 15 mm. Full point. The displacement of the follower is 2. The displacement of the follower is 2. Take place with uniform acceleration. Takes place with uniform acceleration and uniform retardation. Full point. Determine the maximum velocity. Determine the maximum velocity and acceleration of the follower when the camshaft rotates at 900 rpm. 900 rpm. Full point. Draw the displacement velocity and acceleration diagrams for one complete revolution of the cam. For one complete revolution of the cam. Okay, quickly note down given data. So now this is a case of uniform acceleration and uniform retardation. Okay, uniform acceleration and uniform retardation. Okay, now let us go for given data here. So stroke is given 40 mm. Outstroke angle theta naught is given. This is what 100 degree. And theta return. Okay. So theta at dwell on a top position, it is 80 degree. So theta return is given. This is again 100 degree. Okay. So theta dwell is of 80 degree. Is of 80 degree. Right? Now speed is given 900 rpm. Speed is given 900 rpm. Now let us look at the differences in the follower motion. Okay. If it is uniform velocity, so displacement diagram you are going to get, right? So you just going to join the points, okay, from a lower position to the top position, okay, right? Suppose if it is simple harmonic motion, now you need to draw a circle here, right? So you just divide here, then project, okay, you are going to get a curve, right? This is what a simple harmonic motion. Now the thing is that uniform acceleration and retardation is a little different here. Uniform acceleration and retardation is a little different. Now let us go for first displacement diagram when it is subjected to uniform acceleration and retardation. So now take a suitable scale. Okay, so draw one line, that is what AX line or any convenient naming you can take. Okay, you can take any convenient notations. So first I will go for displacement diagram. Okay. Now take suitable scale here. Okay, scale means you go for appropriate length for 360 degree. Okay. So now here I am taking 1 centimeter equal to 10 degrees. Okay. I am taking 1 centimeter equal to 10 degrees. So you can take 1 centimeter equal to 20 degrees. You can take 1 centimeter equal to 20 degrees. That means you need to draw the line of this AX line length is equal to 36 centimeter, which is equal to how much? 360 degree. If you took a scale 1 centimeter equal to 10 degree. Suppose if you took a scale of 1 centimeter equal to 20 degree, then this has to be reduced to 18 centimeter. Right? Now draw the OI line. Draw OI line, so which has to be equal to 40 mm. So now in this case I'll go for 8 centimeter here. I'll go for 8 centimeter. Okay. Now this is what OY. This is what a stroke here, which is equal to 40 mm. Which is equal to 40 mm. Now you just draw a parallel line. Now you just draw a parallel line here. So just make a box. Now divide this AX line. So as angle of outstroke, as angle of dwell, as angle of return stroke. Now outstroke is 100 degree. Now we'll go for scaling here 100. Now dwell is 80 degree. Again return is 100 degree. Okay. Now let us put namings here. So I'll go for A, B, C, D, X is there. Let it be. Now this is what B dash, this is what a C dash. Right? What is the next step? Can someone say? Can someone say what is the next step? ಏನು ಮಾಡಬೇಕು ನೆಕ್ಸ್ಟ್ ಅದ್ರೆ ಇಲ್ಲ ಏನು ಮಕ್ಕೊಂಡ್ರೆ ಹೊಸರ Am I audible or not?
Yes, sir.
So now divide AB portion and CD portion into equal number of parts. Now let us go for dividing this one to 6 number of parts. Okay. So we're going to get a fraction value. So 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5, 6. Okay. So let us number here 0, 1, 2, 3, 4, 5, 6. Right? Now you just join the line. You just join the line. That means you just join the points O B dash here. Okay? O B dash. Now the thing is that to get the uniform acceleration, the curve you are going to get here, it is a sine curve. Sorry, you are going to get a cosine curve here. Now let us mark this as a midpoint here. Okay, let us mark this as a midpoint. Now divide this middle line. That is what line number 3 here is here. You divide this one again, equal number of parts you have done for outstroke angle. For outstroke angle you have done 6 divisions. Now similarly you divide this vertical line, that is 3 number line, into 6 divisions. Now 1, 2, 3, 4, 5, 6. Is it right? Okay. Let us name here. Let us name here A dash, sorry, A, B, C, D, E, F. You got our baseline here. Base point let it be. Now you join the lines for rise and fall. Okay. Within outstroke and now let us join the points here from O to A. ಏನ್ ಮಾಡ್ರಿ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಲೈನ್ ಜಾಯಿನ್ ಮಾಡ್ರಿ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಲೈನ್ ಜಾಯಿನ್ ಮಾಡ್ರಿ ಹೌದಾ ಸೊ ನೆಕ್ಸ್ಟ್ ಟಾಪ್ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಜಾಯಿನ್ ಮಾಡ್ರಿ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಜಾಯಿನ್ ಮಾಡ್ರಿ ರೈಟ್ now wherever intersected so now this A line is intersected point 1 point B here C D E and last point. Now you draw the curve. Now you draw the curve passing through these points with a very smooth curve here. Right? This is what a smooth curve. Now similarly follow on this outstroke also. 1, 2, 3, 4, 5, 6. You got a more latitude. Again you join the lines. Okay. Again you divide a third line. You will get exact mirror profile here because angle of outstroke is equal to the angle of return stroke here. Okay? You will get exact mirror of outstroke profile for return stroke because angle of return is same. One, two, three, four, five. 1, 2, 3, 4, 5, 6. Right. Okay. Now just join the line here. C dash to D. This is what the midpoint. Now divide this line again here. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Okay. Now 3 dash line has to be divided into 6 number of parts. Okay, let us divide here. Now you just join here. right? Now let us mark point intersection points here. Now let us take this G, H, I, J, K, L, M. Now join these points with a smooth curve here. So you will get the profile of displacement in this way. Okay, for outstroke and for return stroke, right? Now for uniform velocity, you got exact straight lines here. Okay, and for simple harmonic motions, you got little curve in this way. Okay, curve in this way. But here you are going to get exactly change in its directions if you draw the line here. Okay, clear. Next, drawing of the profile is same. Again, you measure the distances, you draw the base circle. Okay, and for offset circle, you divide the angles, then you measure the distance and procedure same. Okay. Now you follow the same procedure whatever done for earlier two problems. Now let us go for calculation of velocity and acceleration here. Now let us go for maximum velocity of the follower during the outstroke, okay, and return stroke. So maximum velocity during outstroke and return stroke. Okay. So what is the formula? So V naught equal to pi, sorry, 2 omega s by theta naught. 2 omega s by theta naught for outstroke, and for return stroke, VR equal to 2 omega s divided by theta r. Okay. Right? Now, as angle is same, theta naught equal to theta r, you can just calculate any one value and you can say both are same. Okay. Now, so what is omega? Omega is what? Angular velocity. So omega equal to what? Angular velocity. So let us calculate first angular velocity. So omega equal to 2 pi n by 60. Okay. So 2 pi n is 900 divided by 60. So someone calculate and give the answer here. So 2 pi into 15. Someone give the answer quickly. 2 pi 15. 2 into 5 into 15.
94.24.
94.24 radians per second. Now you got a omega. Right? Now calculate velocities. Two into 94.24. Now S is a stroke. This has to be converted in terms of meter per second. Sorry, in terms of meter. Okay. So theta naught is 100 degree. Convert this one in terms of radians. Okay. So theta naught is how much? 100 degree. Okay. So convert this one in terms of radian. How much radians you are going to get? So now pi radian equal to 180 degree. Okay. So for 100 degree, how much? So 100 into pi divided by 180. How much in terms of radians? Theta naught? ಯಶವಂತರಾವ್ ಕ್ಲಾಸಿಗೆ ಕೊಡ್ಬೇಕಾದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಹಿಡ್ಕೋಬೇಕು ಫಸ್ಟ್. How much did you got for outstroke?
1.74.
1.74. Okay. Now substitute 1.74. Now we calculate what is the velocity out for outstroke.
4.31.
4.31 meter per second. Okay. So again, just say, so V naught equal to VR equal to 4.31 meter per second. So because, so theta naught equal to theta R, which is equal to 100 degree, right? If the angles are different, you need to calculate differently. Okay. Next, you calculate what is the accelerations here. Maximum acceleration for a follower during outstroke and during a return stroke. Okay. So maximum acceleration so what is the formula? A naught equal to 4 omega square s divided by theta naught square. You need to remember these formulas. Okay. You need to remember these formulas. Now already we calculated omega, okay, and theta naught in terms of radians. Okay. So 4 omega is 94.24. It's a square. Now 40 into 10 to the power of 3. Conversion in meter. Okay. So theta is 1.74. How much? 1 point. Theta not ಎಷ್ಟು ಬಂತು ರೇಡಿಯನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದಲ್ಲ
1.74.
Okay, now we calculate.
Four 69.34.
4
69.34.
ಏನ್ ಯೂನಿಟ್ acceleration unit है ना
Meter per second.
right. So we'll go for another 2 problems on this cam profile and we'll close this chapter. Okay. So you may get the drawing of a flat-headed follower, and one more is a roller follower. Okay? So I'll go for one problem on roller follower, and one problem on flat-headed, and one problem on cycloidal motion. One problem on cycloidal motion, right? So now concept is clear how to draw the cam profiles. Or you have still any doubts?
Hello, sir.
Okay. Hello, ಏನಾಯ್ತು?
ಸರ್ ಅದು 6 ಡಿವೈಡ್ ಮಾಡಿದ್ರಲ್ಲ ಸರ್, ಅದು 6 ಮಾಡ್ಬೇಕು ಸರ್.
6 ಕಾಮನ್. ನಿಮಗೆ ಸ್ಮೂತ್ ಕರ್ವ್ಸ್ ಬೇಕಂದ್ರೆ 8 ಡಿವಿಷನ್ ಮಾಡ್ಕೋಬಹುದು ಅಥವಾ 12 ಡಿವಿಷನ್.
ಹಾಂ ಸರ್.
ಮಿನಿಮಮ್ ಡಿವಿಷನ್ಸ್ ಆರ್ ಟು ಬಿ 6.
ಹಾಂ ಸರ್.
Okay, now I'll close.
Yes, sir.
If possible, I'll put one extra class. Tomorrow you have a class, Tom class. Is there? No? Or else? ನಾಳೆ ಇಲ್ಲಲ್ಲ ಕ್ಲಾಸ್ ನಿಮಗೆ?
ನಾಳೆ ಇಲ್ಲ ಸರ್.
ಓಕೆ. ಸೊ ಇದು ಪಾಸಿಬಲ್ ಆದರೆ ಸಾಯಂಕಾಲ ನಾನು ಮೆಸೇಜ್ ಹಾಕ್ತೀನಿ, ಕ್ಲಾಸ್ ಜಾಯ್ನ್ ಆಗಬೇಕು. ಯಾಕಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ವೀಕ್ ಎಲ್ಲರೂ ಓವರ್ಲ್ಯಾಪ್ ಆಗ್ತಾವೆ ಕ್ಲಾಸಸ್, ಸ್ವಲ್ಪ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಆಗ್ತಾವೆ ನೆಕ್ಸ್ಟ್ ವೀಕ್ ಕ್ಲಾಸಸ್. ಅದಕ್ಕೆ ಇವಾಗ ನಾನು ಕ್ಲಾಸ್ ಮುಗಿಸ್ತೇನೆ.
ಸರ್.
ಕ್ಲಾಸ್ ಹಿಂಗ್ ಬೋರ್ಡ್ ಮೇಲೆ ಬರೀ ಚಲೋನೋ ಏನೋ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಬರೀ ಚಲೋನಾ? ಈಗ ಬೋರ್ಡ್ ಮೇಲೆ ಬರೀ ಚಲೋನಾ?
ಸರ್.